Hi guys, so today matters is exact differential equations. Okay, today we are going to speak about exact differential equation. So any exact differential equation, okay, what we mean by exact differential equation and how do we solve problems related to these and things like this. Okay, so for exact differential equation, okay, what we have to do first or what we have to understand first, okay, any differential equation of first order and first degree can be written in this form, okay, like f of x is a function of x, y, and differential of y with respect to x, where where y is what we call dependent variable and x is independent variable. So we are finding the differential with y with respect to x. So, and this first ordinary and first degree differential equation can be written in this form also. So, for exact differential equation, what does it mean? It is a method to solve a differential equation of first degree and first order. How does this method work? That's the point. So we can say that this a differential equation is exact when we have this expression. Okay, we have the equation written in this way. The equation is written in this way. So the first thing we have to do is just to find what is the differentiation of m, okay, of mxy, okay, dx, mxy with respect to y. Okay, we have to find first what is the partial derivative of the polynomial that is multiplying of the function, okay, of the function, this partial function that is multiplying dx, and we have to apply partial derivative with respect to y, okay, and we have to find also what is the derivative, partial derivative of n of xy, okay, with respect to x. Okay, so this partial derivative of m with respect to y and n with respect to x must be equal. So if this is equal, so this is the main condition for any equation to any differential equation to be considered as an exact differential equation. Okay, when the differential of m of xy with respect to y is equal to differential of n of xy with respect to x, just like this. Okay, when this differential is this and this and this, when they are equal. So when this condition is satisfied, what we have to say now, okay, so it means that the differential equation or the general solution for this equation will be given by this integral, will be the integration of m of xy dx. Okay, just take out this one as it is, and integration of this, just integrate this one, integrate this one, integrate this one. Okay, just some change will happen. See, when you integrate m with respect to x, okay, you will have to consider y as a constant, and when you integrate n with respect to y, you have to exclude every terms that is remaining in x. With this, what we mean, we have to consider every terms in x equal to 0. Okay, we have to make x equal to 0. So we will have only terms ending in y, so that we can apply the integration. Okay, let us see. Okay, in a practical work. So we are going to start for this equation. Okay, for this one. As you can see, you can solve also this equation by applying separable method. Okay, because this one we have differentiation of x with the function of x and differentiation of y with the function of y can be solved also by separable method. Okay, but here we will solve applying the concept of exact differential equations. Okay, so here we have this function here we have this function. Okay, now, so what we have to do first we have to find what is m. So here, okay, we know we have just to compare. We have mxy dx plus nxy dy equal to 0. See, just compare what is m. Okay, m of xy will be what? Will be the expression that is linked strictly with dx. So this is 1 plus Euler raised to x. 1 plus Euler raised to x. And n, okay, n is equal to y, because this is the expression linked to what dy. Now, what's the next step to do? Okay, this is n and this is n, m and n. Now find what is dm with respect to y. Okay, and here find what is dn with respect to x. So now let us check. This will be d of 1 plus Euler to the power x and dy, and here d, okay, of y with respect to x. Okay, now see, okay, 1 plus Euler raised to x with respect to y, all here will be constant. This will be 0 directly. And here, what I will get, dn del x will be also 0, because y is a constant when I'm deriving with respect to x. So, as del m, yep, see, as del m and del n are equal, so here, okay, we can say that here del m del y is equal to del n del x, that is equal to 0. Okay, therefore it is exact. Okay, it is an exact equation. So if it is an exact differential equation, so it will be given. What I have to do, I will just to integrate this, and this will be c. Okay, integrate this both side. This will be integration of 1 plus Euler raised to x dx plus integration of y dy equal to c. Now see, because integration of 0 is 0 and 0 is constant, so yeah. Now see, check here. Here we have to understand that this one will be constant. Here y is constant. We have to be aware about this. Okay, y is constant, and here x is excluded. Okay, just excluded. Okay, you have just to exclude any x in there. Okay, so there we have what we have to do. Okay, this is the first step. The first step is this one, find n and find 2. Okay, yeah. So what we have to do now, just integrate this and integrate this. So if you integrate this one, this will be what? X plus Euler raised to x, okay, plus integrate this one, this will be equal to y squared by 2 equal to c, equal to c. Okay, this is the solution for this integration. This is the general solution for this differential equation. Okay, number 1 is done. Let us solve one more exercise. Okay, suppose we have exercise number 2, and this is given like just a minute. Okay, suppose we have this second exercise here. Right here we have this expression. So let us find first what we have to do, compare with this expression mx y dx plus, okay, here you will be what you get, what n of x y dy equal to 0. So here, just by seeing, if you compare, this one is m and this one is n. Okay, so here, okay, m x y will be equal to x Euler raised to x squared plus y squared. Nice. Yes, nice. And what else we can do? N xy is equal to y 1 plus Euler raised to x squared plus y squared. Okay, this is m and n. Now that you know what is m and n, the second step is just to find differentiation. Okay, here del m by del y. Okay, find what is the differentiation of them, and here del n by del x. Okay, just find differentiation of this, guys, and with respect to x and with respect to y. So see, with respect to x or to y, if we differentiate this one, this and this will be constant. So I will get x, this one, x Euler raised to x squared times Euler raised to y squared. Okay, and I will just apply differentiation to this one and the y. Is that okay? It's nice. I just split this one, and I can do this one also with this one, because here I just want x. Okay, because differentiation here will be with respect to x, so it will be y plus del of y plus what? Euler raised to x squared times Euler raised to y squared. Okay, all upon del x. Okay, now del m del y, it will be just derived with respect to y. This will be what? This will be 2y x Euler raised to x square times y square. Okay, just like this. And here del n del x, it will be what? Del n, if you derive this one with respect to x, will be 0. If you derive this one, this will be 2 down. Okay, okay, just you can just check. Hey, sorry, I didn't multiply this by this. Here we have y. Okay, because this one we multiply with this and with this also. Okay, yeah, now it's okay. Del y del x 0. Del y at Euler raised to x square, Euler y square, Euler raised to y square, and y will be constant because here I'm deriving with respect to x. So I will just derive this one, Euler with respect to x square. And if I derive this one, this will be down, x square derived. So this will be plus 2xy, then Euler x square and Euler y square. Just by analyzing this, del m and del y will be the same. 2x y Euler, if you multiply it, will be x squared plus y squared. Okay, and that is the same as del n del x, that is 2x y Euler raised to x squared plus y squared. Okay, if they are equal, what does it mean? It means that this function is, okay, is exact. S del m del y is equal to del n del x. Okay, this is an exact, okay, exact differential equation. Okay, and if it is an exact differential equation, what you have to do, just apply differentiation, just apply integration here, come here, apply integration here and here. This integration right here, okay, you will have to consider as y, you have to consider y as constant, and this integration right here you have to consider as x equal to 0. Okay, this must not be no term of x must be in this differentiation, just like this. Okay, then it will be integration. When you integrate this one, integration of x, Euler raised to x squared plus y squared, and here it is dx, plus integration of y, okay, y plus y, Euler raised to x squared plus y squared. Okay, plus y squared dy. And see, as I was saying, here y, I will consider y as constant. Okay, but here I have to exclude, okay, all terms of x. It is the same as saying like x equal to 0. Okay, now what you have to do, where you find x, you must just reduce x to 0. If you put here x equal to 0, you will remain only with x Euler raised to y square. Okay, so it can be written in this form. Here y is constant, so you take this y constant out. Okay, this y constant out. So this will be x, okay, Euler y square, then Euler x square dx, plus, because here y is constant, so y is constant. Okay, y is constant, out. Okay, then integration. So put here where you find x, put 0. So x here will be 0. This will be only y plus y Euler raised to y square. Okay, yeah, and dy equal to c, Now, is that okay? Now just solve this one. Just solve for this one. For this integration, we know just apply 2 here and take 2. This will be fine. And here also apply 2 and take 2. So that will be okay. Okay, that's okay. So this will be 1 upon 2 Euler y square. Okay, integration of d of Euler x square, plus, now here what you're going to have dy y dy plus, and here the same, take 2 and put 2 here and take 2. What we have, you have this one derivative, so d of y square, okay, is equal to c. Then what you have to do is just solve this integration. Just solve this one. This will be 1 by 2 Euler y square times Euler x square plus y square by 2 plus 1 by 2 Euler y square is equal to c. Okay, as you can see, Euler, you can take this out. Euler y square, Euler raised to y square, you can take out as common here, and this is okay, it will not change anything. So Euler raised to x square plus y square, okay, plus 1 by 2 Euler raised to y square plus y square by 2 equal to c. Okay, equal to c. So this is the solution for the second exercise, and so on and on. Yep. And yeah, in this way you will have this solved. Okay, you have this solved. So the general solution will be given in this way. Okay, in this way, like here you can see this and this. Okay, and this is one. Nice. Then what is the next thing? Okay, meaning that, okay, what is the next step? So for this solution, for this equation, like this, you could see, just write down 1 by 2 Euler raised to y square times Euler raised to x square plus, yeah, this integration you know, okay, 1 by 2 Euler raised to x square equal to c. Yeah, this integration you know, it's okay. Yeah, from here you can just come this and this, 1 by 2 Euler raised to y square, and make Euler raised to x square plus 1, okay, and plus y square by 2 equal to c. Okay, yeah, equal to c. Nice. Let us go for just one more exercise. Okay, just one more exercise. Let me pick up which one. I'm plenty of exercise here. You have a lot of exercise here. So guys, you can just try on this one of these exercise, okay, any one of them, then try to solve, and where you stop, just let us know, and or just okay. So you can solve any of these exercises just applying the same method, the same thought. Okay, so let me solve for which one. Let us pick up a differential equation like this, okay? Because we didn't do this. Let us do this trigonometric, or maybe trigonometric. Anyone can be okay. It's okay. I will solve for this last one. It's okay. Nice. Or maybe this one is okay. Okay, when you have this expression like this, it is to apply, okay, because this is the integration. Okay, this is integration. Sorry, this is dx and this is dy. Okay, dy. So this is integration. This is how can I say, differentiation of y with respect to x. So it means that y with respect to x is equal to 1. It means that y is equal to 1 when x is equal to pi by 2. In the solution that you find here, then you will substitute when y is equal to 1 and x is equal to pi by 2, and you can just find the particular solution, okay, because this is for particular solution. After finding the general solution, then find the particular solution. That's like this one. Let me see, whom are we going to solve with? Okay, let us solve for this one. Okay, no problem. Any one of here, it's okay, but I'd like just to solve for this trigonometric one. This will not change anything. It's okay. Okay, let us solve for this one. We don't have that much time to solve for everything. Okay, let me solve for this one. Okay, this looks like a little bit complex. Looks like, but actually it's not. Okay, dy dx. This is dx. I'm solving for the 10th exercise. Okay, plus 3x4 to the x raised to 4 y square dy. Okay, bracket plus minus 2xy dx, then plus x square dy equal to 0. Is that okay? Okay, now what do we have to do? That's the point. Now let us just solve for this one. For this one, the main point is just you have to separate dx and dx and dy with dy, just like this. So pick up dx here and dx here and dy there, dy there. So this will be 4x cubed y cubed, okay, y cubed minus this and this, minus 2xy dx, then plus 3x raised to 4 y square, okay, minus, okay, minus this and this will be minus, okay, minus what? Minus x square, and this is dy equal to 0. So now that you separated this, you know that this one is your m, okay, m is for x cubed y cubed, okay, minus 2xy, and this one is your n, okay, n is equal to 3x raised to 4 y2 y minus y raised y square minus x square. Okay, derive them. Okay, derive m with respect to y, derive n with respect to x. Okay, this will be 12x square y 12, okay, x cubed y square minus 2x. This is only with respect to y. Then del n, del x, with respect to x, this will be 12x cubed y square minus 2x. As you can see, they are all equal. Okay, so del m del y is equal to del n del x. So it is exact. So if it is exact, so what will be next? So I will have to write the function of m with respect to x, like m dx, where y will be a constant. Okay, y have to be a constant, plus n dy. Here I have to exclude, okay, all terms of x. It means that where I find any term of x, I have to take this part, take it all, okay, take it all, just like this, equal to c. Now let us solve for this one. Now see, if I integrate this expression, okay, I have just to pick up this one. If I integrate this one, okay, I have just to integrate this term and integrate here. What we have, integration of m, this expression, with y constant, okay, this will be, y is constant, so it means that if y is constant, this will be 4x cubed y cubed minus 2xy, okay, dx, y is constant, okay, y constant, okay, plus integration. Here I have to go, what is n? N is this, so I have to take out, okay, all the terms ending in x, all the terms that is depending on x. If you see here, x is here. If I take x cubed, x squared, or x to the power 4, this one will go also, okay, and this one will go also. So all terms are depending on x. It means that here, if I exclude all terms of x, it will be 0. Nothing will remain, okay, nothing will remain, and dy equal to c, just like this. And here what I have to do, just find this integration, okay, take this y cubed, 4 and y cubed are constant, this will be x cubed dx minus 2 and y are constant, then it will be x dx. Integration of 0 is 0, so it will be c. So then it will be 4y cubed, and here x raised to 4 by 4 minus 2y x squared by 2 equal to c, okay, just like this. Then you have just to do some simplification. 2, 2, 4, 4, this will be x raised to 4 y cubed, okay, minus x squared is equal to c, okay, then you're done, okay, yeah, then this is the equation, this is the solution for this equation. But see, do not forget this one, okay, we cancel 2 and 2, 4 and 4, cube here, and here we have to have a y, okay, do not forget this one, okay, do not forget, it's fine. One more exercise, okay, let's go, just to have the concept, because actually this is very easy, okay, when you got the point, it will be very, very, very easy for you to just solve any exercise. Let us go for this one. Let's try for this exercise, because we have this one. This is sinus. This is the last exercise that I'm going to solve, okay. 3, we have sinus hyperbolic of x times cos of y dx minus cos hyperbolic of x sine of y dy equal to 0. Now see what we get to do, okay, it is already in this way, in this form, so here m is equal to sinus hyperbolic of x times cos y, and n is equal to cosinus hyperbolic of x and sine of y. Okay, what you have to do, just apply derivative, okay, like partial derivative with respect to y for m, and partial derivative of n with respect to x. Okay, this is what you're going to do. If I apply dy, sinus hyperbolic of x times cos of y, and here cosinus hyperbolic of x and sinus of y, okay, dx. What you're going to do, that's the point. Now apply integration. So apply derivative. Okay, this will be first, it is a product, so this will be first this one derivative, it will be cos hyperbolic of x, okay, and here you get cos, it is with respect to y, it means that x will be constant, so it will not change. Sinus, okay, this will be sinus hyperbolic of x, sine hyperbolic of x, and cos of y. What is cos of y? Cos of y, derivative with respect to y, will be minus, okay, sinus, okay, will be minus sinus of y. Okay, so it will be minus sinus hyperbolic of x times sinus of y. Now let us go for the next. Here, if I derive with respect to x this cos, okay, if I derive with respect to x this cos, this is negative, okay, don't forget this one, this is negative, and here it's negative. So cos hyperbolic of x, this is sinus hyperbolic of x. It is not negative, it is sinus hyperbolic of x, okay? Yeah. Because in hyperbola, it's like cos hyperbolic and sinus hyperbolic are both even function. Okay, so there is nothing like cos hyperbolic of x is equal to minus sinus hyperbolic of x. It is not like this. Okay, as they both are even, so cos hyperbolic of x and sin hyperbolic of x are the same. Okay, no change. Okay, no change in the signal. Okay, so cos hyperbolic of x, this will be sin hyperbolic of x. Okay, and sine of y, so as we are deriving with respect to x, so this will be constant. So this is sinus of y. That's it. Just compare, this is the same, they are equal. So del m, del y is equal to del n, del x. So it means that they mean that the function is, it is exact. Okay, differential equation. So if it is an exact differential equation, what we have to do now, integration. Okay, integrate this part and this part. Okay, just integrate this part. Okay, integrate this both part. This will be sinus hyperbolic of x, okay, time cos of y dx. Okay, here y is constant. Y is constant. Okay, minus integration of what we have to do. See, here I have to excluding all terms in x. Okay, exclude all terms in x. So if I exclude all terms in x for n, just let us see. If I take this one out, this will be 0, suppose. Everything here will be 0 too. So this will be 0. Okay, this will be 0 directly. Okay, 0 dy equal to c. Okay, just like this. So what we are going to have here, this cos of y is constant, come here out. So this will be cos of y and integration of sine hyperbolic of x dx minus 0 is equal to c. So what you're going to have here, this will be cos of y and integration of sine hyperbolic of x. This is directly cos hyperbolic of x, okay, equal to c. This will be the solution of your equation. So I hope you may enjoy it, and you can also come here and solve all of this exercise just to you to feel like, okay, it's fine and you understood well the concept. Thank you very much. You can solve all the exercise that I did. Now, for the next lesson or for the next video, we are going to speak about non-exact differential equations. Okay, we are going to see the 5 types of non-exact differential equation, and after that, we are going to study the Leibniz equation. We mean linear differentiation, linear differential equation, like Leibniz equations. You know what's Leibniz equation? This is like questions like this, okay? Whenever we have dy upon dx plus p of x, okay? P of x, and here we have p of x y plus equal to q y qx. Okay, this is what we call Leibniz equations. Okay, then after Leibniz equation, we are going to see something like Bernoulli's equation. This is a kind of Bernoulli's equation. This is a particular case of this Leibniz equation. This is when you have this one, dy upon dx plus 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 like px, and here you have n minus 1 equal to qx, okay, qx y raised to n, okay, y raised to n. Yeah, this kind of equation. And here what you have to do, just this substitution, y equal to n plus by 1, and yeah, and you have then apply, after doing this substitution, you will have to apply all the method that you, all the ways, all the steps that you use to solve Leibniz equation, this equation here. Okay, and it's okay. Thank you. See you when I see you. Stay with us.